advanced a bit into into smart contract development. So the very first step when you are dealing with anything advanced in smart contract development is looking into upgradable smart contracts. And that is where we would start from today. So first I'll give more this how the class is going to go. I'll give more like a little teaser on what smart contracts is again, then back again to we say smart contract is untamperable, we can't touch it. So how come we can upgrade it and change what it does? So is that not a security flaw? Then we'll see why it's not and how projects do handle upgrades and see how it's done in production. So that's going to close it for my session. And there's going to be a little assignment to build an upgradable ERC20 token contract. So that's what's going to close it from my side. Then ETT is going to take you much more deeper into more complex stuff with upgradable smart contracts and more stuff again. So starting up, we know Ethereum is a blockchain. So smart contract is used in many other blockchains, but most blockchain models, Ethereum's way of doing smart contract. So we would use Ethereum or mention Ethereum more often in this session. So Ethereum is a blockchain, and it allows you to place in softwares in that blockchain that runs according to the accords, like logic you place in that blockchain. So if you have a smart contract that pays you salary every 30 days, the contract always does that until maybe the blockchain destroys and it can't pay any longer, or you run out of funds from where this money is coming from. So in high sense, smart contract just abides to the rules that you set it to do and does nothing more, nothing less. But now we are coming in to say that you can upgrade a smart contract, meaning that if I've created a smart contract that's paying you $1,000 every month, I can upgrade the smart contract to say, oh, this guy have messed up, I don't want to pay him again, and it stopped paying you. So is that not a problem for us saying, oh, it's a smart contract and it's immutable? Once it's deployed, nothing change, code is law. So that's where the problem, where something looks like a problem comes from. So first thing we'll do now is we know this could be potentially a problem. Let's understand how people upgrade smart contract first. Then we'll see how they solve this problem of saying code is law. Who has the power, or who should have the power to upgrade a smart contract and change its logic? So will be on my drawing board again. Good place to be at. So this is our smart contract and have two functions really. It's a bank. You deposit tokens. Okay, let me just increase that a bit. Yeah, deposit token. And you can withdraw. So these are the two functions in my bank, and it has a storage variable where money goes to. It's called Uche's wallet. So in Uche's wallet, that's where all this money that is deposited to, or interest or whatever fee they're paying goes to. So this is the basic smart contract. So now, ideally, if I just write this smart contract like this, users deposits and withdraw their money from this smart contract, and I just deploy this to the blockchain, is not upgradable. So I cannot tamper with it. I cannot change the logic. Whatever thing that is set in this contract is set in stone. So now, how would someone achieve upgradability? So first thing we need to talk about is delegate call. So if you might want to write this down, in Ethereum, there are two major types of calls. When you are calling, when I say call, I mean interacting with a smart contract, interacting with a wallet address. There are two major types of calls. There's a normal call that's just called. Most person call this low-level call. And there's another which is called delegate call. So you could write this down. Delegate call is the core principle behind smart contract upgradability on Ethereum. Delegate call is the core principle behind smart contract upgradability on Ethereum or any other blockchain that uses EVM. All right. Okay. One second. Okay.
Okay, can you hear me? Hello?
I can hear you.
Okay, we're seeing your WhatsApp screen, that's fine.
Because you.
Hello, developer chair.
Yeah,
We can't hear you. I don't know if, okay, I can hear you now, but we weren't hearing you.
I can hear you.
Sorry?
Yeah, I can hear you now.
Okay, yeah, I can also hear you now. All right, please continue.
Okay, let's give us a minute. We're trying to cast on the location here, so everybody here can see my screen also. Yeah. No, thanks for speaking. I can't proceed if we are not casting.
Are you using mic? Are you using mic? Okay. Speaker not be big enough for everyone to see. If you have done, just done like this now. That'll be mouse, right? That'll be mouse, right?
My God, this one.
We have it.
All right, you can see the screen.
Can you see you choose? Yeah.
Are you muted?
No, I'm not. I'm not muted.
So it's not. All right. Sorry for the. So we're speaking about calls. So there are two major kind of calls on Ethereum. There is a normal call and there's another called delegate call. So whenever your wallet tries to transfer Ethereum or call a smart contract to transfer USDC, it's just a normal call to the USDC contract address or a normal call to the address receiving your it's. All right. Okay. So, but now we want to talk about delegate call and let's see what makes it different from other kind of call. So first and foremost, delegate calls are usually called by another contract. So delegate call is just a kind of call that's, let's say contract A has a state variable called, let's call it owner, and is equal to Uche. and contract B has a function, has a state variable called owner also. And this is dummy something. Then, but contract B has another function called set owner. That takes in a parameter of somebody, of a human. Let's put it that way. So if you pass in any human here, it's going to be the owner of the contract. So it could be Gabriel or someone else. So now, this is what delegate call does. Delegate call, let's say contract A wants to call contract B to set owner. But the crazy thing now that happens is when contract A calls contract B set owner, instead of setting this contract B's owner from dummy to whatever contract A is passing, it's going to set it on contract A. So let's go through it again. So contract A wants to set or wants to make a call to set owner and it's passing David as the parameter. So now, normally what you're expecting is the owner variable here in contract A will change from dummy to David, right? But that only happens when it is normal call. When it is delegate call, it changes Uche here to David, not dummy. So the logic, what I want you to have in the back of your mind is when a smart contract calls another smart contract via delegate call, anything that happens in the state, like any variable that changes, any balance that changes, all happens in the calling contract instead of the called contract. Yeah. Yeah.
The others things given that have contract
Yeah, please come in.
others
Okay.
how does it come into given that we have initial contract owners as Uche and Dami.
Yeah.
So how does David come into play?
Okay. All right. So this is I think I didn't stage the story well. So this contract A is owned by Uche. Contract B is owned by Dami. But contract A does not have any function that can change the contract owner from Uche to someone else. And now David wants to pay Uche to be the owner of contract A. So now the tricky thing is this contract A does not have a function to change the owner. It's a smart contract. We cannot just add new function on the go. I want you to add this function to change the Uche's contract unless it's upgradable. And that's what we're talking about today. So this is how you not achieve a contract being upgradable. Another contract entirely that has that function, yeah, entirely, contract B, that has that function, set owner. So instead of now contract A making that call, set owner and changing the state variable from Uche to David because it can't, it will then call contract B. Take this name, David. I want you to set the owner to David. But the tricky thing now is contract B cannot just go to contract A's storage and change Uche to David. So what contract A would then have to do is to call contract B via a delegate call. Now, before you miss it, so the principle of delegate call just states that when a call is made from contract A to contract B, the state change that happens in contract A. So if contract A is calling set owner from Dami to Uche, instead of Dami to change to, from Dami to David, instead of Dami to change to David, Uche rather would change to David because it's a delegate call. So that's the role of a delegate call.
So a normal course being the solution whereby it replaces contract A totally instead of it being like a delegate call whereby it only changes the owner function.
No. So if it was a normal call, instead of Uche to change here, Dami will be the one to change. Because like, let's put it this way. CV. Take this. So this is what's actually happening. Contract A is calling contract B to set owner of contract B to David. So ideally, this should change Dami to David. So this is what's going to happen if it's a normal call. But now it's a delegate call. A delegate call is going to still call contract B. But whatever contract A is intending to change in contract B would happen in contract A. So that intention of changing owner, instead of changing contract B, contract A's owner would change rather. Even if contract A does not have the function to change owner beforehand. I know this does not make complete sense, but first, do you just, can you imagine it being possible? Or can you see the big, let me not call it the big picture because it's kind of a small picture. Can you see what we're trying to achieve and the difference between delegate call and normal call? Okay.
So that's like completely right now with A.
Mhm.
Probably the husband side.
Yeah.
But then contract B is contract B. So I feel like contract A in a normal call,
Mhm.
contract A can tell contract B that change this particular have like final say
Yeah.
on the issues of contract B, like
Yeah.
any change I want to occur from your part, they move this particular name,
Yeah.
this name. But in a delegate call, we see that ownership is changed not only for the family A,
Okay.
but family A also gets to change also. In the sense that family B does not have any change at all.
Yeah.
But family A is the one that takes the new name, right?
Yeah.
That's
Yeah, that's it.
right. Yeah, it's
Yeah.
Just to be sure. So is it that, is this the process at which you can upgrade a contract? Like very contract.
Yeah.
So is it the process to which the smart contract will be edited since the existing smart contract does not have a function to be edited? And then you know be what to change the function, which is the don't understand the
Yes. That is the core principle. So before the end of my session, we then see how you can now like switch. And I want to, in this case now, I really wanted to change for now. What if I wanted to add the logic to buy stuff or so in this case now, you just only want to change for now. What if I wanted to add the logic for my contract now to be a bank, and I still retain this owner Uche or something? So this logic does not exist anywhere. I can just deploy another contract that delegates to that guy. All right. So far the scenarios, the complex stuff, everything makes sense now. Makes sense. So now we've understood what delegate call is. So now let's just look more let's just say in principle or exactly what you would be building. So everybody know what's an ERC-20 contract here, have you? Okay, so everybody have heard about USDC, have you? Everybody have heard about USDT. So all these guys are just ERC-20 contracts. We see them as just tokens or dollar. So that's like the dollar representative on the blockchain. So this ERC-20 contract now, it has few functions. One of them is transfer. Another one is mint. So let's say we are building an ERC-20 contract for a client, and we have these two functions to transfer and mint. But our clients in the future, in the next 3 months, will want us to add a new function called bond. But remember, our smart contracts is immutable. So there's no way on Ethereum we can just wake up one morning and add one function to be able to bond tokens. That's to reduce the supply of that token. So from our scenario now, can anybody just tell me how we could achieve that? From what we've talked about, contract A, B, storage, and owner stuff, delegates call, yada, yada, yada. Okay. Okay, so we have a client that wants to build the next USDC, and they gave us the contract to build that USDC. We've added the transfer function so that allows him to transfer money to me, allow me to transfer money to someone else. And we've added the mint function that allows the owner to create more of this money, just the way they print more money, like the CBN and other bodies print more money. So that's have been done and tested working fine. But the client have already let us in, or have anticipated that in the nearest future, we would want to bond these tokens. So in the next 2 months, I'll call you again to help me add one other function to bond tokens. But no, our client doesn't know anything about blockchain, and she don't know that, or he don't know that you can't just wake up one morning and add new functions to a smart contract. So all we have to do now is to make sure our smart contract is upgradable. So in the next 2 months, you can add the new function. So can anybody think of a way we can achieve this, in that we deploy this contract today, in the next 2 months, we can come and add one other function to bond tokens?
So the idea I've not worked on database code before, but from what you've explained, I'm thinking maybe the contract B, which is the one that's supposed to change the function, maybe create a new contract and deploy it. So it interacts with this existing contract. So we send out the request, then it updates it with that function, which is the bonding function in the smart contract code.
Yeah, so that's very correct. But we now want to arrange it in a way that it looks more like an engineer builds this. So this is how we then do it. So this is our main contract. It wants to transfer and it wants to mint token. That's all it wants to do. But we are not just going to deploy this on the blockchain. We are going to do something first. So remember what we spoke about in delegate call. When you delegate call to another contract, any change that contract logic is supposed to do will happen on you instead of the contract you're calling. So what we will then do is we have to be smart. So we will then create another contract that we will call a proxy. So this is the name that you usually call all this kind of contract. So now, this is now going to be the real contract address we'll send to our client. So whenever our client or our client's user calls this contract, perhaps to transfer or mint, perhaps to transfer or mint. You see, there's no transfer or mint in this contract, yeah? It will then delegate call to this other contract. So whatever transfer or mint operation that happens, the state change will happen here. So perhaps Uche have a balance here of 50. And Gav have a balance of needs to do is then going to talk to this other guy. Hey, Uche wants to transfer. How do I perform a transfer operation? Then to tell you, oh, go to this storage. Uche have a balance here. Take out of this balance and put it in this other guy. So that's state change. So you just get instruction on how it's going to do the state change from another guy and does it on itself. So that's exactly what delegate call does. So the logic to do this is in this other contract. But instead of changing anything in this contract, the change is going to happen on this guy. So the thing that makes this very upgradable now is anytime our client now needs new logic, all we just need to do is to rewrite our contract, add the new logic. So in this case, it's to bond. Yeah. And instead of delegating call to this guy, we just switch our arrow to this guy from the proxy. So we can do this over and over and over and over again. Exactly. So this is where all the data is stored. Just the logic comes to these other guys when need be. So if we're tired of this guy, need some other stuff, we deploy another one and point it to the new implementation. So just for consistency's sake, when you're reading, this guy is always called a proxy. This guy is not called logic, it's called implementation. So there's a proxy contract and an implementation contract. So in essence, this is how smart contract observability is actually. So is there any question? All right, no question. So we'll just go over an ERC20 contract that is upgradable. Let's just see how all we've talked about in the board looks like in code. And that's going to end my session. So it is going to be taking the next session, which continues from upgradable smart contract for something more interesting. So this is an upgradable ERC20 contract. It's quite old, but it works well. So I'll drop this on Telegram after the call. So if you could see my screen well, see we have implementation and we have a proxy. So in this implementation, that's where all the ERC20 contract related stuff is. So that's things like the approve, the transfer, what else? The transfer from the permit signs for something else. Let's see the mint, the bond, which was the new function we added. So this is how the ERC20 token implementation is going to be. That's logic that we will talk to. But this is not how our storage, that is our database per se, would look like. And that's what we call the proxy. So I'll have to talk about something here. It's quite a scary code because, you know, it's in assembly, but all it just does is whenever you make a call to it, it's proxies that call, it reroutes that call somewhere else. And that's what just this logic does. So does anybody know what a fallback function is? Yeah, a fallback function. Okay, just a teaser. So, you know, we say if you call the proxy contract, it's going to relay this call to the logic and get, oh, this is what I'm going to do to get this done. But the real functionality that makes that possible is this guy called the proxy, the fallback function. So on an Ethereum smart contract, let's say like from our example that has transfer and mint. When I've not added bond, if I try to add bond here, it's just going to fail because no, there's no bond function. Why are you trying to call a bond function? But you can now add something that's called a fallback function. Okay, sorry for the break again. I don't know why this stopped. There's my fault. This one. So our users don't know what's contract A, don't know what's contract B. So they just know that you have transfer, you have mint. When they call this proxy, transfer and mint does not exist in the proxy contract. So what the proxy contract then does is to call, the fallback function is called. Then in the fallback function, that's when it then delegates call to whoever has the logic that they're trying to do. So that's like that routing mechanism. It happens because the fallback function has the routing mechanism. Yeah.
So there will be decision that was made by the stakeholder,
Mm-hmm.
which is the owner of
Mm-hmm.
So we made a decision that we should the initial decision that was made to either transfer on it.
Yeah.
And so okay, we're looking for a bond function now.
Mm-hmm.
Initially you said that from this stakeholder decision,
Yeah.
down to the proxy was supposed to be delegated to the contract.
Yeah.
So now how then do we have double delegates if we are placing the arrow at the initial contract, and there is another fallback function there also that now delegates? Can it be?
No, they can't be two delegates, just one.
That-
So it's not as if, no, this fallback is not here. It's in this place.
okay, proxy.
I was just using that to explain.
Sir, I'm both confused at this stage. You said something about you want to delegate, you want to add the bond function. You
Mhm.
said you copy this to contracts.
Yeah.
This thing, then you add the bond function.
Yeah.
So are you redeploying into the blockchain?
Yes, you are deploying the new contract on this blockchain.
So why can't you just create a new contract entirely, then just add the function?
Okay, so the reason why we don't want to just create a new contract entirely is just, for instance, if I try to send me USDC and I send you USDC address, you check Etherscan, you know this is USDC. So what if USDC upgraded to another contract and deploy a new contract? So I can't just send you down. Down is the other people that has the former USDC. Their tokens are now worthless.
Yes.
So they want
We
to,
know
okay.
some crypto projects do that.
yeah.
They will say V1, V2.
Yes. Those ones is, I think it's for much more like, it's not so fertile. Like something like USDC, they try it, they will scatter the crypto economy. But let's say Uniswap, they can do that because on V1, you can swap here. On V2, you can swap here. On V3, you can swap here. So you can choose which one you want to then go to and swap. Well, there's no need to upgrade Uniswap. It has a lot of liquidity to go around. But if you try something like that with USDC now, people will start going crazy that they want to swap to the new one and scatter the market. So it's not just for scenarios like USDC. Some other guys just want to retain one address over and over for a long time. So that's why they employ that. So so far everything makes sense. Yeah. Awesome. So I'll drop this on the group. So what I want you to do is to build an upgradable ERC20 contract. But I don't want to see this exact code. This is just like a roadmap that you can follow. This was written 2 years ago, so it's very outdated. So that's for that. And I think with that ends my session. Thank you very much. All right.
Great. Thank you very much.
Unmuted.
Can you hear?
Let me do that.
Uche, can you hear me?
Okay, so I think. Okay, so what's the time frame to for the attendees to submit the?
Can anyone hear me?
Okay. All right.
I'll drop more details, more research.
Okay. Please, is anyone else on our Telegram? All right, I will share that now. That's Nigeria.
Uche, can you hear me? Can anybody hear me?
Yes, yes, we can hear you. Please go on. Hold on, please.
Okay, so great session, Uche, by the way. So for the attendance, yeah, sorry about that, guys. Just a minute. So yeah, great session again, Uche. It was quite interesting for me, and I'm sure it was interesting for a lot of other people. Just a minute, I'm trying to get the attendance. Okay. Please, Uche, can you help me stop sharing your screen so that I can bring it up? It's a QR code, so everybody can scan. There, guys, can you see my screen?
Yes, you can see your screen.
Okay, so please do scan and of course fill the form for the attendance. And of course, we'll be giving out proof of attendance, so proof of attendance NFT. So please make sure you double check the Ethereum wallet you're also sending. So I'll let this be for a while I iterate over next part, which is of course we're going to look at a simple example of what our able lead dev, which has been able to put us across. Basically, the idea of upgradability. So we're going to look at an implementation of a diamond storage, right? So this diamond storage actually it helps to actually it enables upgradability in smart contracts, meaning that you can separate your logic um, from your storage. Like the last question that was asked, just to throw in. Now, the reason why, like Uche said, the ERC20, if you now deploy a new smart contract instead of upgrading it, so all the tokens that the former smart contract holds becomes worthless. And these tokens are actually stored in storage. So basically, the idea of upgradability in smart contracts is that you separate your logic from your storage. So your storage does not change, but you can always change your logic, right? So, but the storage is always constant. So all your state variables, they are always constant, while the implementation of how you want to interact with those state variables, you can upgrade that through the proxy. So we're going to look at a simple implementation of how we can separate our our logic rather, from our storage. So then we'll look at, this is actually like an intro. There's a standard called the Diamond Standard, ERP2535. You can go through it, but we intend to do a series in our upcoming workshops on that. But we'll just look at that simple implementation where you can write a smart contract and you don't have any state variable, like you don't declare any state variable in your smart contract, but then you can read and write to storage, right? So yeah, we'll look at that in a minute. Please, if anybody has any question, you are free to ask, of course. And also, please have everybody scanned. I'd like to know if everybody have scanned. Okay.
Yeah,
Sorry?
everybody have scanned.
Okay, I'll still send it to you. Of course, we'll still display it later in the screen. So yeah, I'll just stop sharing my screen and then let's look at Remix for our simple, of course, implement. Oh, I'm not even sharing my screen. Okay, please confirm if you can see my screen.
You can see your screen.
Okay, thank you very much. All right, so guys, we'll just jump straight into it. We are familiar with Remix. So we'll just create a new file. and then we'll call our file, what do we call it? Let's call it diamond storage, right? So diamond storage dot show. Okay, yeah, so the first thing we do, as always, we of course declare our license identifier, SPDX. Of course, then we declare our Pragma version. Okay. We're going to use a lower solidity version for this implementation. The reason why is because with the upgrades in the new, I don't know if any other person experiences it, but when I use the new account associated with Remix, the Cancun account, it kind of like gives error. So normally I just try to use a lower version to be able to compile. Okay, but that's out of the way. So now, like I said, we are going to separate our logic, our storage from our logic. So, and also I mentioned that with the diamond storage, you are able to actually build or create a smart contract that doesn't hold any state variables. You can do this, of course, by having your storage, your state variables in a library, right? So your state variables are in a library, and then using a struct, you can be able to reference these state variables and have them like the idea is basically every time you want to, okay, let's go down to the idea of storage on the blockchain, right? So every state variable is stored in a slot, right? So if I have like unsigned int, let's say, what do I call this number, right? Let's say unsigned int number, and then I have like I need to declare probably. I see, okay. Break. So why is it giving this?
You are not in a contract block.
Oh, yeah, sorry guys. So first thing I need to declare the contract. Yeah, it happens to a lot of, yeah. So okay, no, let's just say contract test. Right, so we have a state variable unsigned 256, and we'll call this number, and then we have a string, call it text. So basically, at this point now, this is a slot, right? So this is slot 0, and this is slot 1 on our storage, right? So basically, every state variable is actually stored on the slot. But now we want our smart contract. We're not going to declare any state variable, but then we want our smart contract to be able to get a storage, a slot, every time we call or we try to update or retrieve data from the slot. So what it does is it just gets kind of like dynamically gets a slot that we predefine for it. So every time we call that storage, it's going to access that particular slot on the blockchain. So I know it sounds a bit not clear. Feel free to ask questions, but let's look at it so that at least we have a better understanding, right? So to do that, we first of all, we're going to store our storage. Remember, I said that the storage does not change, but the implementation, the logic can change. So we are going to first of all store our storage in a library, right? So let's say library. What do we call our library? Let's say storage library. Okay, so we have our library. And inside our library, we want every time we are going to have two state variables. Let's say we'll have an unsigned integer and a string, right? So we'll try to get their value and then also update their value. So that we know that we actually made a state change, right? So to hold this value, we are going to use a struct. So we don't want to declare any state variables, right? So we want this memory to be in this struct. The reason why is with this diamond storage, of course, you can always upgrade your smart contract in terms of the logic, and then your gas fee would be reduced to a certain high extent, right? Because now you are not having state variables, but you can actually interact with the blockchain and have every time you call any of your state variables, you are going to allocate a particular slot that will dynamically get that slot for you. So it kind of like saves gas, and you can always upgrade your logic. So like I said, we're going to have, let's call this string, what do we call this string now? Let's say A or something. And then, excuse me, we'll have an unsigned int of 256 character, I'll call it B. So this is where we are going to this is actually what we would use to actually interact on the blockchain on a slot. So every time we call that slot dynamically, we are going to be able to retrieve data from these two variables. They are not state variables, but we'll be able to retrieve data from them. So yeah, after that, the next thing we're going to do is we're going to select a slot where every time we need to retrieve this information, we are going to get it from our slots, right? So to do that, normally we just declare a constant in bytes because storage on the blockchain is in bytes. So we actually want to get that byte 32. I think I have an error. Why is the error? Okay, I did not name my struct. We'll call this, let's call it records, right? So yeah. Okay. All right. So like I said, we're going to assign a storage. Like what I mean is we're going to assign a storage slot. We're going to assign a storage slot for our record structs, so that every time we try to read or write, we are going to use this slot to actually access these variables. So like I said, storage on the blockchain is in bytes. So we have a byte constant to make our value constant at all time. Then normally you can name it the naming convention. There's no naming convention, so you can probably name anything you want. So for here, we'll just call this, let's call this storage slot, right? So for convention, I'll put it in capital letters so that I always know that I'm referring to this slot. So of course, any questions so far, please feel free to ask questions. So now we are going to encrypt any text. It doesn't matter what you put in. It's just that once you encrypt it, it's going to get that byte. And then why I said dynamically earlier is that it's dynamic, right? So it gets the hash, and then that byte at that hash, we're going to use that hash to locate a slot on the blockchain. So that slot we locate is where we are going to actually be interacting with. So let's, using Kika256, we're going to encode, it could be any text at all, right? We could say encode BV. Then once we encode this, at this byte on the blockchain, that is where our storage will be, right? That's where the slots will be. So, but for clarity, you can name it anything, but I'll just name it, what do I call it? Okay, let's say manage storage dot slots. Just for convention, you can actually put any text you like there. So now we've gotten a storage, we've gotten our struct. Then the next thing is like this. When Uche was showing us the upgradability, he showed us something in assembly in YAWL, right? So basically, YAWL is a low-level language that you can use to interact with the EVM, right? So we're going to use assembly to tell our contract every time we call this storage slot, locate this using the byte of this storage slot, locate that memory on the blockchain. So that's where the assembly will actually come in. So it's like a pointer to this slot. So like I said, I'll just put some comments here to get the pointer to the record structs. So this pointer is actually this storage slot. Remember, we're getting a byte 32 from our encoding or our encryption rather. So at that byte 32, at that memory on the blockchain, that is where our slot will be. So now we're using the assembly, the low-level language, to actually point our smart contract to that particular memory, right, to that particular slot. So we'll now use a function actually to do that. We need a function to do that. So to get our slots, get slots or get storage slots. I think storage slot was better. So get storage slots. We're going to pass in the byte of our storage slots, of course. So we want at this particular memory, at this particular byte, right? So give us that memory on the blockchain. So we pass a byte 32 of the slots we need. And of course, this function will be internal because it's going to be pure because it doesn't change the state of the contract. We are just getting storage. We are not doing any smart contract manipulations, right? So we're going to get this at our struct. So it's going to return us that memory at that struct in storage. So let's call this records. So basically, we are returning that storage at that particular this particular slot you are passing, this one. So basically, we are using this slot and then using this constant slots. Remember, we are going to return the of course the bytes at that slot actually. So it's just a low-level function that is going to point our smart contract to that slot, that memory, to be able to access the variables. So yeah, so I'll call the assembly language, which is YAWL. And then okay, and then we are going to tell it to get that records for us at that slot. So dot slot is actually a method where we are accessing the slots, right? So as declaring this variable and assigning it to whatsoever slots we pass in. So basically, what using assembly, we are getting these records, right? So you pass in these slots, and then we are assigning this slot to this slot on our struct record, right? So I hope that makes sense. So it's just a pointer pointing the smart contract to that memory. So yeah, for the string, I think maybe we'll just come back to this. All right, let's just go ahead. All right. So now, since we have two variables, so I'd like us to implement both of them. Maybe for the unsigned, for the integer, the unsigned integer, let's try to do a little manipulation, right? So just something so that we don't just store a value and retrieve it. Let's have it do some work for us, right? So let's do a simple addition, right? So we'll just add two numbers and then get the result at that slot. So yeah, so let's just have one function to add that, let's say function add norms. I think that works. So now we're going to pass in two numbers. We want to add number A, and then we want to add number B. And then we're going to add the memory, right? So every time we call this add function, we are going to tell the smart contract to do it at a particular memory, which is this our storage slots, right? So remember, in our function to get the slots, we are passing in our storage slot, which is the hash rather of a byte 32 of our message. Yeah, this message could be anything, right? So we're passing these slots and we're telling our smart contract that we want to add all these function add number, get it at these slots for us, right? So we'll pass in our slots also. It's a byte 32. Remember, byte 32, let's call it slots, right? So what this function will actually do is going to be internal. So what this function will actually do is just, it's not going to return anything, but we're going to get our struct, our storage. Let me not call it struct, right? So let's go and get our storage, which is our struct. We'll call it a variable, say record. Then we're going to get the storage, right? Well, first of all, get the storage slot at this slot you are passing in, right? So once we do that, we are going to then get our struct record, record. We are going, remember, this is slot. If it was a state variable, like I said, this will be slot 1, right? And this will be slot 0. So since we are doing unsigned integer, we want to get this particular variable, right? That's where we want this function to actually implement the storage, right? So at this point, we are going to get the records.b, and then we are going to say just add our a plus b for us. So we know that we have done some state manipulation, right? We've taken two variables, two numbers, and then we add it, and then we store it on our storage, but in this particular storage, which we had declared already as an unsigned integer, right? So once we store it there, that's just what we want that to do for us. For the string manipulation, we can just pass in a string and try to read it. So basically, this is the structure of our library. So now, this is our storage, right? Remember, we're talking about upgradability. So now we have our storage. It will not change, right? Or it does not change. So now we can now go and now create or develop a smart contract, which is upgradable, right? So we can always change the smart contract, but then point it to the same storage, right? So that's the idea of separating your logic from your storage so that you can always upgrade your smart contract. So now we now have our contract. What do we call our contract? Let's call this implement logic. I think implement logic. Okay. So first we need to use our library, which we created above, which is of course our storage, right? So we first get our storage. So we're using what's the name of our library again? Storage library. So we're using storage library for everything because we want to call everything in the library, right? All right. So let's try to implement the addition, right? So let's try to add two numbers and then get the result. So we have a function that does that. Let's say function, we can still call it add nums, doesn't matter. So our function will take in two variables, right? Unsigned integer 256 number 1. Let's use numbers here. And then take in another number, number 2. So we're going to add these two numbers remember, it's going to be an external call because it's an upgradable smart contract. So all our calls have to be external, right? Except, of course, I think there is no reason to have an internal or private call in your implementation, since your smart contract will always be dealing with another smart contract or a library, right? So your calls have to always be external to enable other smart contracts be able to call your contract also. So it's going to be external. Okay, no, we are going to return. No, we are not returning. Our library doesn't return, right? Yeah, so we won't be returning anything, but we'll get maybe another function to actually get the results for us. So the first thing we do is to call our library, right? Our storage. So our storage library. Now on our storage library, we want to call our record struct, which is actually our variable, which in a sense is our state variable, is our state variable, right? So we'll call our variable. This will be capital letter. So storage library dot our records, and then we're going to get that record at that place, and then we're going to call. Now we're going to pass in the slots. Remember, we have a function that every time we need to point our smart contract to our storage, we have to call this function, right? This get storage function. And the get storage function takes in a slot, right? And this slot is what we use to actually direct our smart contract to that particular memory on the blockchain. So implementing that, we are going to call a minute, guys, sorry. All right, I was trying to look, I think I missed something. So yeah, I'm having this right here, so I think I missed something. Okay, let's just continue, see where it goes. All right. Okay. Okay, guys. So yeah, I've seen what's causing. So now we have this function to add numbers. So we're actually going to call this function because already in this function we are getting our memory, right? So we don't have to be redundant. So yeah, we just call the function directly instead. So we say storage dot add num, right? So remember, it takes in 3 parameters, right? What are they? If number A, number B, and then the slot. So we're going to pass in, of course, our own variables, which is num1, I think num1, and then num2. And then remember, in our function, we're also passing a slot. So now we're going to pass in this slot, this particular memory, right? So we're going to tell the smart contract to get the byte and then using that byte to locate this particular memory on the blockchain. So I think this storage slot, so I'll just get that. So then our third parameter will now be our storage library, which is our memory, our storage library. Library dot our slots, right? So now we have gotten our slots. All right, I think that should be it. So now we have a function that is actually going to add 2 numbers and then dynamically get our storage and then store it on this slot. So now we also need to retrieve these results, right? Because we're not returning anything, right? So to get the results, let's have another function to get at number. So this function would be external, and then it's view, right? Because you are not changing anything. I just want to get the results. Then we are going to return, of course, an unsigned integer. So what do we want to return? At this point, we're just going to get our storage record in the storage and then return whatsoever is in this slot. So this is what we want to return, right? So we're just going to get, using our storage library, we're going to get our records and then we're going to return what's in this slot. So to do that, we call, of course, first our storage. Excuse me. Then we get our records, right? So at our storage, let's call this still record. We're going to return, we're going to get our memory, that's the storage itself, library. Then we get our storage. What's the name again? Get storage slots. So we're getting our storage slots, right? Okay. So get our storage slots at, remember where we are getting our storage slots, we are getting these storage slots, right? At our storage library, at our storage slots. So we then get, of course, our storage library again. Then we get our storage slots. And then we want to return whatsoever we get. We want to return B, which is the second one, right? So we're returning our record here, which we've gotten. So we're returning our record dot B, right? So basically, we can be able to add numbers and then get whatsoever. But notice that our smart contract actually has no state variables of its own. We're getting our state variables from this struct, which is not technically a state variable, but we had found a way, or rather with upgradability and of course EIP 2535, it's very possible to actually use this method to save gas and of course to implement upgradability in your smart contract. So we'll just try this out. Or I think we have another storage. Okay, let's just do something for the string, right? Let's just pass in something and then retrieve it so that we are sure both of them are okay. So for our string, we'll just get a function that will update our string. Let's call this update text. And then we're going to pass in a string because we are getting a string back. So passing in a string, which we call text, and is external. So what we really want to do is we just want to change the our text here, our string here. Right now it's empty. So we want to be able to add data to this variable and retrieve data from that variable. So we'll just get it, then just like we did in the first one, again, get another function that is going to get the value for us. So first we're going to just update the string or the variable on our struct, right? So first we get our storage. Normally, we're getting our storage library. Or rather, we are instantiating our storage library, right? So we're getting it, then we'll get the records. And then at that storage, what we want to do, let's call this variable record. What we want to do is we want to be able to change the text, right? We want to change the text at normally this storage, this location. So it's probably the same thing with what we've been doing so far. So yeah. So now just copy this. I won't type out everything. So I'll just copy this and then we have our storage there. And what we want to do at that storage is we want the record dot is A, I think. Yeah, string A. So record dot A want to store our text in that storage, right? So basically what we are doing is we are getting our storage and then we are implementing our logic right here. To also get the value there, shall I just go ahead and copy this? Basically the same thing. So I don't type all over. So yeah. So we'll call this function get text, get text. And then here, instead of returning slot B, we just want to return slot A rather, right? Okay, it's returning now. We need to return a string here because we are getting a string memory. Yeah, so now we can be able to return our string, right? So yeah, let's try to compile this also. Hope it compiles. Yeah, so we've compiled this successfully. So basically, just to go over what we did, we separated our storage from our memory, from our logic rather. For our storage, we're using a library to actually store our variable, and this variable using a struct, and then we are telling our smart contract that every time we need to update values, these values which will use our state variables. So at this memory, which of course it could be anything, right? So that's why I say it's dynamic. So once you change this text here, which could be anything, automatically you are locating another memory, right? So it's dynamic that way. So we're saying for our smart contract, always get us the memory at this slot. And then once you get that memory, do some things, add some numbers, and then update the text. So now that I've compiled, we'll just go ahead and deploy it. Please, any questions so far? Any questions? Uche, are you there?
Yeah.
Yeah, we're asking if anybody have any question.
Okay.
I'm trying to ask if any of the attendees has a question. So I'm waiting for them to respond.
Okay, please, if anybody has a question, all right, I'm here to take it before I proceed.
Is it just deploying on the base test nets? This is only solidity, so that's where my question is.
Sorry, I didn't get you. What did you ask, please?
I was saying, since the title of today's program is smart contract development with base protocol, so I was asking, where does the base protocol come in? Is it only? I can hear you, sir.
Yeah, please go ahead.
Is it just the deployment on the base test nets, or there's something we're integrating into the smart contracts?
Okay, yeah, the idea is using upgradable smart contracts, we'll be able to deploy smart contracts and interact with them on base. So yeah, base comes in because everything will be deployed on base and the interaction will happen on base. Now, base also offers a lot of advantages compared to other blockchains, right? So of course, like I mentioned at the beginning, that this would now be like a series into the Diamond standards, and then with base protocol, rather, as we proceed further, you would see the importance or the benefit of using base protocols for your upgradable smart contract. So this is like an intro to a series. So we're going to be talking about more advanced stuff as we go. And then we'll just want to take it one step at a time, right? So for now, everything will be deployed and interacted with on base. And then in our subsequent series, I think you will get a bigger picture. So we don't want to try to bring in so many things so that we don't end up confusing you guys, right? So yeah, that's it. I don't even answer your question.
I think that does. Yes,
Okay. All right. Awesome. Any other question? Okay, so I'll just go ahead and let's deploy this and see how it goes, right? So, okay, so then we're going to use our injector MetaMask. I need to change my network. Uh, okay, check. Right. But first, before I even deploy normally on base, so let's just test it out here. I need to get my base wallet in. Let's try it first on Remix, see how it goes. Hope we don't get any errors. Okay, it's copying on my injector MetaMask, which, yeah, okay. Let's try. I always have issues here. I'll try London. London has been fed to me, right? So he's giving me the address. So if I try this other guy, I have to wait for a long time. He gave the address today. Wow, wonderful. Okay. That means today is a good day, right? Okay, so let's just deploy this, right? So let's look at what we have. So now we've successfully deployed and then, okay, so that's fine. We're deploying our library. No. We want to deploy our implementation, right? So normally we don't need to deploy this library, so I'll just delete that. Let's deploy our implementation rather. So now we've deployed it and then, okay, great. So now we have just these two interactions where we can add numbers, we can update the text, right? We can also get the number, the value for what we've done. So normally if I do this now, I'm supposed to see, okay, getting our number is 0, and then getting our text, of course, is empty because there's nothing on our storage, right? Remember, our smart contract doesn't have any state variables of itself, right, to reference, but it's going to use the storage on our library to actually implement all of this. So let's try text. Let's say development on base. So let's try that. Okay, great. I think we didn't have any error after all I was expecting. So so what we did was we were able to call our update text function in our implementation logic. And then if you go to our implementation logic, I'll just make this 50-50. Yeah. So in the update text, remember we're getting our storage from our library, right? So we've been able to dynamically assign a storage on the blockchain and be able to actually read and, okay, we've written to it. Let's see if we can read from it. So yeah, we can actually read from it. These are development on base. So if we change it, let's say advanced smart contracts. So we update it again, successful, great. So now you see that we have actually implemented our storage without actually having state variables. So let's do some manipulations also. Let's add, let's say 1 + 1. And if we transact successful, so if we get our number, it should be 2, right? So yeah, we're having 2, and if we change it again, random numbers, not our random numbers. So the blockchain is actually doing our manipulation for us, right? So we've been able to actually successfully build, not build, but be able to separate our logic from our storage. And then we're able to, using our logic, we can interact with that storage and of course, read and write to that storage at that particular dynamic location. So basically, that's one of the advantages of upgradability. And then as we proceed, of course, like I said, we're going to be diving deeper and deeper into all of this. But yeah, before that closes, I think I need to deploy on base. Yeah, so I'll just get my base I'll just get my base. Let's see. Um, Does anybody have any questions so far, please? This will be the right time to ask.
There's no question for now.
Okay, so I want to deploy this on base, so just give me a minute, guys. And then I'll share, of course, the hash with you guys. So I want to deploy it on base Sepolia. Okay, so yeah, I don't know if you guys can see my screen. Let me try sharing it. Okay, just a minute. Yeah. So I had to change browsers because my base test wallet is actually in another browser. So I'll just create not here. Okay, so I just create a new file storage, diamond storage. So and then paste our functions. So now I can easily connect to my base to deploy. So what do I want to deploy? Yeah, I want to deploy my mission. Is somebody saying something?
No, no, no.
Okay. Oh no, not not that much. Let's see. So this base OX14. Okay, so yeah, I have the right account now. So yeah, I want to implement my logic and then I can deploy my logic. Okay, I think, yeah, we have a transaction confirmation. Let's see. Okay, so we've successfully deployed our first of the series in our Diamond standard, our first Diamond storage. We've successfully deployed on base. And of course, this is our contract, which of course, I'll just drop it in the chat. So you guys can also check it out. So that's, of course, our smart contract which we deployed on base. I know some people would like to see the code after. So I think what's the best way to send you guys this? Do I push it to GitHub? Do I share it as a file? Okay. So yeah, I think that's that for me. Please, I'm going to share the attendance scan code again, so you guys can register. And while you are doing that, I'll try to see how I can push this to GitHub and then get the link, so everyone can have access to it also. All right. So Uche Adesun, over to you guys.
Thanks a lot. All right, so while we wait for the attendance to go around, it's been an interesting session, I must say. I know some. Okay, is that the attendance? Okay, please let's scan.
Yeah, this is the attendance.
Yes, we are yet to. I think that's the same one we scanned the other time, right? Okay, so we don't have to do that again. All right, so please, the best way I can say, I think the best way to learn this and to understand it better is by doing. So yeah, so when you do that and then you deploy, you'll be able to understand better the the smart contracts and its logic. So what I would suggest we do is maybe should we just actually we are having a light issue here. It's a big problem for us. So I don't know. Do you think we should just play around with that with the library, or should?
We'll not be able to play around with that
All right.
now.
Okay.
We understand the process, but the code is much more technical.
All right. So I've been informed already that we may be given about 4 to 5 days for us to be able to attend to the assessment. So please let's try our best. Okay, then for the Ethereum, please let me drop our Telegram channel so that you'll be able to join us on Telegram. Let me do that quickly. If you're yet to join our Telegram channel, please let's do that now so that you'll be able to get updates on how to attend to the. All right. Let's go to Telegram and search for Ethereum Nigeria. Ethereum Nigeria. Yes. So that's our Telegram channel. You can find it there. So in case you are yet to join, I think there's someone here who's yet to join us. You can just fetch our Telegram channel and then join us there so that you can get the updates from there. It's very important. Then also our Twitter handle. It's Ethereum Nigeria. Trying to get our Twitter handle. All right, so that's our Twitter handle. All right, twitter.com/Ethereum Nigeria. I don't know if I can have the permission to share screen so that you can see. Okay. 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 Tete has shared the codes. So can you see it there? So what we can do, okay.
Really, can you make this like a GitHub gist so you can have a link on
I'm actually
Telegram?
trying to see how I can copy that and then put it on a Telegram channel so they can fetch it from there. Yeah, I think that will.
Okay, I'll also do the GitHub gist right now. Maybe we'll share the link in the channels.
Sure. Okay. Yes, yes, that's the community. Okay, so please go to our general platform on Ethereum Nigeria Telegram and then fetch there's a file there. I'm going to be sharing it now. Okay. Okay, I shared the file advanced smart contract logic .txt. So just go to our Telegram channel. So you can just have the logic, understand it well, study it very well, so that when instructions about how to attend to your assessment be passed out, you understand how to go through it. All right. And like you've heard already, that it's not that you have to follow it word for word, but you have to understand the logic, the implementation, and everything like that, so that when you are doing yours, you you'll be able to do that and get it straight. And also, let's be at the back of our mind that this is just the beginning. So please buckle up. All right, buckle up. Like I always encourage, the learning is in doing, not just in watching, and it's in doing. So the more we get to learn, I mean, the more we do, the more we understand. Like, for instance, you're trying to deploy a code and then you see that it's not working, and you'll be surprised that what's going on now? That challenge is what makes you to like want to understand, why is this not happening? Why is this not working? Yeah. So, but when you watch and then it's just like Rosie is moving straight, you think, oh, let me do that. It's gonna move straight. It might not be like that. So it's in the doing. Let's try to engage. Let's try to do. So have you joined the team? Okay, have you seen the file I just shared? Okay. So please, let's try to engage. You do, and then try to get on your hands dirty, your feet dirty, and then you get to understand better how it works out. Okay, then the form, the attendance form. Let's try to fill that under. Okay, I know. Just give us your assessments about the whole stuff, what you want us to work on, and all that. Your ideas, your contributions are well appreciated, please. All right, then we'll be having more of updates coming up soon on our Twitter. What I want us to do is, you see, when you get this update, this information, don't just keep it to yourself. You understand? You are far better off 3 months ago on blockchain, about blockchain and blockchain knowledge. Yeah, 3 months ago, who we were then is not who we are now. You understand? Yeah, that's just it. I mean, when someone's talking about Web3 and blockchain, then what your mind would just go to is what? Is what? Yeah, crypto. That's all just be like, oh, crypto. But then it's you know it's more than that. I mean, imagine someone who's not here today now, and then you're talking about advanced smart contract development. Yeah, what's that thing? I thought it's just about the sender and you get exactly. But now it's way more than that. Exactly. So imagine when you just keep diving deeper and deeper into that, and then you keep your boots dirty. Trust me. So it's a lot. It's promising. It's fun. Yeah, for real, for real. So this is what I would like to say. Please, let's get engaged and get things done. I don't know if Uche, if you have any encouragement to also share. I think it's, yeah, because sometimes like the coding, you realize, what am I doing now? Until now deploy, I say, oh, okay. Exactly. Exactly. So there's need for encouragement. There's need for you to know that you're not wasting your time. I don't know if you were here the last time when Shane was here. Yeah. I mean, he was talking about stuff, and I'd be like, really? I mean, people are thinking. Yeah, they are. People are really thinking. They are doing great stuff on this. But it's not. No, it's not just about now. It's about starting a Facebook now that's going to boom like in the next 10 years. When he was doing that, people like, I mean, are you crazy? What are you doing? You're wasting your time. But hey, look at it today. You're not even talking about Facebook, we're talking about Meta. Yeah, so it's a big project that you have to look at. It's futuristic. Like I said in the morning when we were doing the intro, it's futuristic. It has a lot of promising future that you can never imagine. Those guys that are persisting and I say, hey, and all that, don't worry about them. Later on, when they begin to understand it and they jump on it. They jump on it. So, and lastly, think more about the use cases. This is what will make you to be productive in engaging the blockchain. Think more about use cases, think more about solving problems with it. And then you can solve problems when you think more about use cases. How can I really use this? It is then that your creativity can come out in developing smart contracts. You feel challenged and you want to get some stuff done. Yeah, so I'll that's where I'll stop now. I don't know. Yeah, Uche, over to you.
Well, hi guys, can anyone hear me? Are you guys there? Yeah, can you hear me? I don't know if you guys can hear me, but
I have a question.
yeah, can you hear me?
The session. When we talked about the session earlier,
Yeah.
you said something about delegate and normal, yeah?
Yeah.
So, though delegates was quite understandable by me, but is there a case where, can you give me a case where normal code is used, or is it not used in contract development?
Yeah, normal call is using contract development. That's like maybe you want one contract to call another contract, or this time around to update his own storage, not yours. Yeah.
So all this is your story, not yours. So you are like contract A calling contract B,
Yeah.
undermining whether it has a set owner parameter of human,
Yeah.
undermining that doesn't.
It don't have to be separate now, it could be something else completely. So let's take for instance, Uniswap calling USDC contract. So Uniswap can be calling USDC contract to, oh, this guy wants to exchange USDC for one kind of shitcoin or something. So Uniswap is going to deduct USDC from you to give you the shitcoin. Uniswap has the shitcoin in possession. So it's then going to talk to the USDC contract that, hey, this young man wants to take out tokens from me. He has approached me to take away from his token. So Uniswap calling USDC this time around is going to affect the state change on USDC, not on Uniswap. That's just a normal call.
Okay, so following up on your explanation, so basically this normal call is more appropriate towards exchanges, not really update on contract development.
Yes, it's not just exchanges, anything that requires two contractors to communicate. Normal call is used. Delegate call is mostly used only regarding a contract that is upgradable.
Updates and upgrades. Yeah, all right, thank you very much. I really wish that base guy was here and does not over. Yeah, yeah. Also, I didn't really vibe. I didn't really vibe. It was on the screen now.
Yeah.
On YouTube, right? Which can I get in contact?